Welcome to True Projects. In this video, we are going to explain about the project title Development of a Platform for Network Intrusion Detection System. Before diving into the execution, let me give you an overview of the project. Let us first understand what Network Intrusion Detection System is. A Network Intrusion Detection System (NIDS) is like a security guard for computer networks. It watches all the data moving in and out of the network, looking for any unusual or suspicious behavior. If it sees something strange, it raises an alarm to warn the network administrators so they can take action to protect the network from cyber attacks. The main aim of the project is to develop a robust platform for detecting and responding to network security threats, enhancing cybersecurity defenses, and protecting network infrastructure effectively. Traditional methods in network intrusion detection system (NIDS) include signature-based detection for known threats and anomaly-based detection for abnormal behavior. Packet inspection and rule-based filtering are also utilized to scrutinize and control network traffic. But these traditional methods have some limitations, such as inefficiencies in detecting unknown threats and high false positives. Challenges like scalability, inability to inspect encrypted traffic, and the need for constant updates highlight the necessity for advanced techniques to effectively tackle evolving cyber threats. So, in this project, in the base paper, the author has utilized decision tree classifier, KNN, K nearest neighbor, CNN, convolutional neural network, and LSTM, long short term algorithms to monitor and detect network intrusions and anomalies. It pre processes raw data, continuously evaluates traffic, and triggers alerts for potential threats. Responses are initiated based on ongoing evaluation, ensuring adaptability to evolving cyber threats. But to further enhance the performance, we have proposed voting classifier and combining models like CNN plus LSTM. These approaches aim to enhance accuracy by combining predictions from multiple models and leveraging the strengths of different architectures to effectively capture spatial and temporal features in network traffic data. This enhancement aims to increase the system's ability to detect and classify network intrusions with precision and robustness. The main aim of the project is to predict the presence of attacks and to identify the specific types, including denial of service, DOS, normal behavior, malware infections, SQL injection attempts, and virus attacks. Models are trained on labeled network traffic data to distinguish between different intrusions. By accurately predicting attacks and their types, the system provides actionable insights for organizations to respond promptly and mitigate risk effectively. In the project, we have evaluated algorithm performance using metrics like accuracy, precision, recall, and FN score. These metrics calculate how well models detect and classify network intrusions. Analyzing these metrics guides informed decisions on algorithm selection and deployment, enhancing cybersecurity defenses and risk mitigation. The project benefits organizations, individuals, cybersecurity professionals, society, and regulatory bodies by enhancing cybersecurity measures, improving online safety, providing advanced threat detection tools, facilitating regulatory compliance, and promoting trust, economic growth, and societal well being. To implement this project, we need software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Algorithms used. These are the algorithms which are proposed in the base paper. But to further enhance the performance, we have proposed a hybrid model named CNN plus LSTM and a voting classifier. First, let us understand CNN plus LSTM. CNN plus LSTM algorithm offers a powerful approach. Convolutional neural networks, CNNs, are adept at extracting spatial features from network traffic data, identifying patterns within individual packets or segments. On the other hand, long short term memory LSTM networks excel at capturing temporal dependencies in sequential data, making them ideal for analyzing network traffic over time. By combining CNNs and LSTMs, this approach allows for a comprehensive analysis of both spatial and temporal features in network traffic data, potentially enhancing the system's ability to detect intrusions and anomalies effectively. Coming to the next algorithm, which is voting classifier. Another valuable algorithm for the development of a network intrusion detection system platform is the voting classifier. This ensemble learning technique combines the predictions of multiple individual classifiers to make a final decision. In the context of NIDS, various models trained on different aspects of network traffic analysis are integrated through voting. By combining the predictions of multiple models, that is, random forest and decision tree, the voting classifier can improve the overall accuracy and robustness of intrusion detection, leading to more effective cybersecurity defense mechanism. Now, let us execute the project. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the dataset folder. In this project, we have utilized NSL KDD dataset. NSL KDD dataset is a benchmark dataset for intrusion detection featuring realistic network traffic data with various attack types like DOS, probe, R2L, and more. This dataset is pre-processed to remove redundancy and it is widely used to evaluate intrusion detection systems. In this folder, we have the text document for train and test datasets. So here, this is the data set which is used to train the models. So these are the features related to network traffic characteristics and are commonly used in the context of network intrusion detection systems. These features provide valuable information about network traffic behavior, which is used to identify and classify different types of network intrusions and anomalies. So here, this is the label column which tells us the type of attack which is being detected. So here we can see that various attacks are detected. Some of them are normal, Neptune, Eep, Eep sweep, back, pod, Wes client, teardrop, and more. So this data set will be pre-processed and then it will be used to train the models. Now close this data set. And here, this is the test data set. So these are the features related to network traffic characteristics and are commonly used in the context of network intrusion detection system. These features provide valuable information about network traffic behavior, which is used to identify and classify different types of network intrusions and anomalies. So here, this is the label column, which tells us the attack type. So we have different attack types, which are Neptune, normal, back, nmap, pod, pot sweep, teardrop, and more. This data set will be pre-processed and then it will be used to test the models. Now close this data set. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are Python source files which will be used in the project. This is model file which contains the algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to user information. This is the sample data set which will be used during the execution in the front end. So here we have the features related to network traffic behavior, which is used to identify and classify different types of network intrusions and anomalies. Now close this data set. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to enter all these details to register. But I have already registered, so click on sign in. So here we need to enter the username and the password, which are static, and then click on sign in. We have logged in successfully and we are redirected to the prediction page. These are the features related to network traffic that are commonly used for network intrusion detection system. So here we need to enter the value of these features, and after entering the values, the application will predict whether attack is detected or not, and if attack is detected, what type of attack is detected. Before entering the values, let us understand what these features are. So the first one is protocol type. This refers to the protocol used in the network communication, such as TCP, UDP, or ICMP. The second one is service. It indicates the type of service or application being used, such as HTTP, FTP, SSH, etc. This information helps in identifying known services and their associated behavior. SRC bytes, that is source bytes, the number of data bytes transferred from the source to the destination in the network connection. This indicates the size of the data payload being transferred. DST bytes, that is destination bytes, similar to source bytes but indicates the number of data bytes transferred to the destination. Land. This binary attribute indicates whether the connection is from or to the same host or port. This is an indication of a potential attack if it is set to true, as it suggests a land attack where the source and destination IP addresses and ports are the same. Wrong fragment, it indicates the number of wrong fragments received in the network packet. This can be an indication of a fragmentation attack. Number of failed logins. Number of failed login attempts. High values indicate brute force or other password guessing attacks. Logged in. Binary attribute indicating whether the user is logged in. An unexpected login can indicate unauthorized access. Coming to the next feature, which is root shell. Binary attribute indicating whether root shell access was obtained. Unauthorized root access is a significant security concern. SU attempted. It is a binary attribute indicating whether an SU root command was attempted. This indicates an attempt to escalate privileges. Number of shells. Number of shell prompts. Example, command prompts open during the connection. Multiple shells open can indicate suspicious activity. Number of access files. Number of accessed files during the connection. Unusual high values indicate scanning or reconsensus activity. Number of outbound CMDs. Number of outbound commands executed. In normal scenarios, this value should be 0 as clients typically do not issue commands to servers. SRV count, number of connections to the same service as in the current connection in the past 2 seconds. This helps in identifying patterns of service usage. Same SRV rate, percentage of connections to the same service as the current connection. It helps in understanding the behavior of connections to the same service. SRV different host rate, percentage of connections to different hosts among the connections to the same service. This helps in identifying scanning activities. DST host SRV count, number of connections to the same service from the same destination host. Helps in understanding the behavior of connections from the same host. DST host same SRV rate, percentage of connections to the same service from the same destination host. It is similar to same SRV rate but focuses on connections from a specific host. DST host server rate, percentage of connections that have same SYN errors among the connections to the same destination host. SYN errors are indicative of port scanning or other malicious activities. DST host SRV server rate, similar to DST host server rate but focusing on connections to a specific service. These features provide valuable insights into network traffic behavior and are used in the development and evaluation of network intrusion detection systems. Now let us enter the values of these features. So I'm entering the values. So here I have entered the values. Protocol type is 1, service is 24, source bytes is 263, destination bytes is 345, land is 0, wrong fragment is also 0, number of failed logins 0, logged in 1, root shell 0, so attempted 0, number of shells 0, number of access files is also 0, number of outbound commands 0, SRV count 4, same SRV rate 1, SRV different host rate 0.5, destination host SRV count 255, destination host same SRV rate 1, destination host server rate 0, destination host SRV server rate is also 0. Now click on predict. So here we can see the result. There is no attack detected and it is normal. Now let us enter another set of parameters. Click on home link here. Now I'm entering another set of features or parameters. So here I have entered the features. Protocol type is 1, service is 20, source bytes is 334, destination bytes is 0, land is 0, wrong fragment is also 0, number of failed logins 0, logged in 1, root shell 0, SU attempted 0, number of shells 0, number of access files 0, number of outbound commands 0, SRV count 2, same SRV rate 1, SRV different host rate 0, destination host SRV count is 11, destination host same SRV rate is 1, destination host server rate 0, destination host SRV server rate is also 0. Now click on predict button. So here we can see the result. Attack is detected and it's malware attack. Now let us enter another set of features. Click on home link. Now I'm entering another set of features from the sample data set. Protocol type is 1, service is 24, SRC bytes is 263, destination bytes is 345, land is 0, wrong fragment is 0, number of failed logins 0, logged in 1, root shell 0, SU attempted 0, number of shells 0, number of access files 0, number of outbound commands 0, SRV count 4, same SRV rate 1, SRV different host rate 0.5, destination host SRV count 255, destination host same SRV rate is 1, destination host server rate 0, destination host server server rate is 0. Now click on predict button. So here we can see the result. There is no attack detected and it's normal. Now let us enter another set of features. Click on home link. I'm entering the features now from the sample data set. So here I have entered the features value. Protocol type is 1, service is 60, SRC bytes, that is source bytes is 1506, destination bytes is 1887, land is 0, wrong fragment is 0, number of failed logins is 0, logged in 1, root shell 0, SU attempted 0, number of shells 0, number of access of files is also 0, number outbound commands 0, SRV count 1, same SRV rate 0.01, SRV different host rate 0, destination host SRV count 6, destination host same SRV rate 1, destination host server rate 0, destination host SRV server rate is also 0. Now click on predict button. So here we can see we got the result, attack is detected and it's virus attack. Now let us enter under set of parameters, click on home. So here I'm entering under set of parameters from the sample data set. This is the data set which I have already shown you. So from here I'm entering the features value. Protocol type is 1, service is 49, source bytes is 0, destination bytes is 0, land is 0, wrong fragment is also 0. Number of failed logins 0. Logged in 0, root shell 0, SU attempted is also 0, number of shells is 0, number of access files is also 0, number of outbound commands is 0, SRV count is 1, same SRV rate is 0.01, SRV different host rate is 0, destination host SRV count is 0, destination host same SRV rate is 0.02, destination host server rate is 0, destination host SRV server rate is also 0. Now click on predict button. So here we can see we got the result, attack is detected and it's SQL injection attack. Let us enter on the set of parameters. Click on home link here. So here I'm entering the values from the sample data set itself. I'm entering the values now. So here I have entered the values. Protocol type is 2, service is 12, SRC bytes is 45, DST bytes is 98, land is 0, wrong fragment is 0, number of failed logins 0, logged in 0, root shell 0, SU attempted is also 0, number of shells 0, number of access files 0, number of outbound commands 0, SRV count 270, same SRV rate 1, SRV different host rate 0, destination host SRV count 254, destination host same SRV rate 1, destination host server rate 0, destination host SRV server rate is also 0. Now click on predict button. So here we can see the result. There is no attack detected and it's normal. In this way, just by entering the features, we can predict whether attack is detected or not, and we can also predict the type of the attack depending on the features which we have entered. Now click on graph link. So here we can see the correlation analysis. It tells us how the variables are correlated, and here we have the comparison graphs for the evaluation metrics precision, accuracy. So here on the x-axis we have the accuracy score and on the y-axis we have the algorithm name. So the algorithm which is performing best will be used for prediction. So in this project, voting classifier is performing well compared to the other algorithms, and that is the reason it is deployed in the front end. And here we have the HMM iteration. And here again we have the comparison graphs. On the x-axis, we have the score for each evaluation metrics, and on the y-axis, we have the algorithm name. And here, this is the R2 comparison graph. On the y-axis, we have the algorithm name, and on the x-axis, we have the algorithm name, and on the y-axis, we have the score. So, in this way, by entering the features, we can predict the different types of attacks, that is malware, virus, SQL injection, or normal. Now click on sign out button.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.